South Shore Construction builds permanent docks and seawalls along the southern shore of Long Island, New York. Although the firm has been in business only 5 years, revenue has increased from $308,000 in the first year of operation to $1,084,000 in the most recent year. The following data show the quarterly sales revenue in thousands of dollars. Construct a time series plot. What type of pattern exists in the data? So here's the plot that Minitab gives us, and we can clearly see a seasonal trend because of the up and down nature of the time series. But there's also a linear trend here as well, because over each year revenue looks to be increasing. Use the following dummy variables to develop an estimated regression equation to account for seasonal effects in the data. Quarter 1 is 1 for quarter 1 and 0 otherwise, quarter 2 is 1 for quarter 2 and 0 otherwise, and quarter 3 is 1 and for quarter 3 and 0 otherwise. So in other words, quarter 4 is going to be the reference level in this example. So using Minitab and those dummy variables that we just defined, the estimated regression equation is y hat equals 70 plus 10 times quarter 1 plus 105 times quarter 2 plus 245 times quarter 3. Based only on the seasonal effects in the data, compute estimates of quarterly sales for year 6. So all I do here is the forecast for quarter 1 is going to be the overall intercept 70 plus the 10 that's in front of quarter 1 in the equation, so that comes to 80. For quarter 2 we'll have 70 plus 105, which comes to 175. For quarter 3 we'll have 70 plus 245, which comes to 315. And then for quarter 4, which remember is the reference level for the dummy variables, we'll just have the overall intercept 70. So these are clearly not very good forecasts for year 6 because we're not taking into account the linear trend. So let period equal 1 refer to the observation in quarter 1 of year 1, period equal 2 refer to the observation in quarter 2 of year 1, and so on all the way up to period 20, which refers to the observation in quarter 4 of year 5. Using the dummy variables in the previous part and this new variable period, develop an estimated regression equation to account for seasonal effects and any linear trend in the time series. So now we have this estimated regression equation, and this accounts for the linear trend. And based upon the seasonal effects in the data and linear trend, compute estimates of quarterly sales for year 6. So now to get these forecasts, for example, for year 6 quarter 1, we'll have minus 70.1, which is the overall intercept, plus 45, because this is in quarter 1, plus 11.68 times the period, which is 21, and that comes to 220.1. The forecast for the next period would be minus 70.1 plus 128.3 because it's quarter 2 plus 11.68 times 22, and that comes to 315.1. And then we can do a similar thing for the forecasts for the next two periods, 455.1 and 210.1, and these are much better forecasts than the previous forecasts, which didn't take into account the linear trend that's clear in the time series plot.